Hello everyone again. Happy to have you with us on the Top Voices channel and our community talk series. My name is Sofia and today our guest is Ivan Timonov. He's a development operations engineer as well as machine learning operations engineer at Tabby. Today we will discuss cloud cost control, getting the most from GCP for startups. This session covers how to cut cloud waste and optimize cost with Google Cloud's built-in tools. And let's get started. Ivan, please, the stage is yours.
Hello, everyone. Thank you for joining. I'm Ivan, an MLOps engineer at Tabby, a UAE-based BNPL fintech unicorn. Today, I'm sharing a practical way to bring FinOps discipline to Google Cloud without heavy tools or month-long projects. A familiar picture, bill spike once in a while, nobody has time to deep dive, no dedicated FinOps team, and yet you still need control. My goal is a simple, repeatable framework you can roll out in a couple of sprints. First, make costs visible, then set up a few standards to stop waste, and finally automate those standards so they don't rely on discipline. This talk is aimed at startups and small teams already running on Google Cloud who want to manage costs more effectively without deploying complex FinOps platforms. The common scenario is firefighting, a sudden spike, ad hoc reaction, then everyone moves on until the next surprise. The shift we are making is from one of dives into a predictable process that runs quietly in the background. Before we optimize, it's important to know where money usually leaks. These aren't rare edge cases, they're patterns you'll see again and again. I'll walk through the most common ones and then show how to fix them with native GCP features. First, idle and oversized computes. Think Vertex-side workbench instance, especially with GPUs, left running after experiments with no auto shutdown, or forgotten virtual machines that nobody uses anymore. Google Cloud Engine node pools sitting idle without auto-scaling, which is especially painful when GPUs are involved. And oversight cloud SQL node pools or virtual machines that were never right-sized. Next, BigQuery. Heavy scans happen because of select all queries over large tables or missing partitioning and clustering. Temporary datasets and tables are left behind and never cleaned up. And a big one, staying on on-demand billing when your workload is already steady enough to benefit from capacity pricing model. Google Cloud's storage sprawl is another source of leakage. No lifecycle policies, so logs and build artifacts just sit in standard storage class for months. Forgotten temporary buckets that never get deleted. Excessive logs and metrics. Logs and metrics are all set up without filters and you keep everything. Retention is set for too long by default, and over time, the line item grows quietly until it's not so quiet anymore. Finally, orphaned resources. Disks left behind after deleting some virtual machines and old snapshots that nobody needs. They're easy to miss, but they steadily burn budget. Sorry. Yeah. The key idea is that these are normal patterns, not exceptions. The good news is they are solvable with built-in GCP tools like billing reports, budgets, labels, and small weekly habit of reviewing recommendations. From here, we will use a simple framework. Visibility standards and automation. Step 1, visibility. Make costs clear and attributable. Set up cost breakdown by project, services, or labels. Enable budgets and alerts. And if needed, export billing data to BigQuery. The goal is to see on a single screen where your money goes and who is responsible. Step 2, standards. Introduce a few light rules that eliminate 80% common leaks. For example, mandatory labels, e.g. owner or team or environment. Off hours for non-production environments, basic practices for BigQuery, Google Cloud Storage, or compute, plus regular work with GCP's built into the recommendations. And step 3, automation. Lock the process in so it doesn't rely on people's discipline. Create schedules for resources, regular checks, and simple quotas. And if the team uses Terraform, create basic policy checks at plan stage, e.g. labels required for or public IPs use only when they're needed. First, start with 3 simple questions. Every cost view should answer. What is the most expensive? Who owns it? And when did the growth start? For that, the standard billing reports and cost breakdown are enough. One screen with breakdowns by project, services, and labels. Second, define the minimal labeling scheme and make it a rule. Owner, team, environment, optionally GPU, true or false. Practically, this means no new resources without these labels and existing ones tagged at least for the most expensive workloads. A short one-pager with label dictionary helps avoid spelling variations. And third, set up budgets and alerts as early warning signals. Thresholds at 50, 80, or 100% are enough, but routing matters also. Alerts should go not only to email, but also to a shared chat where people will actually see them. Each budget or resource must have an owner, the person who either reduces this spend or consciously approves it. Fourth, establish a 30-day baseline and weekly ritual. Review current spends, note top 3 cost drivers, and each week revisit the same 3. What changed, why, and what direction? Fifth, optional but sometimes might be useful, enable billing export to BigQuery and then build a very simple Looker Studio dashboard with spans by project, servers, labels, plus trend line. A single page that answers the same 3 questions from step 1. And finally, initial KPIs to know you're out of fog. 100% label coverage for new resources, share of unattributed costs close to 0, budget alerts arriving before overruns, and a backlog of actions decided and executed after weekly reviews. Once the practices are in place, you'll see where the money goes and who owns it. Once you have a basic visibility, the next step is to agree on a simple rules that eliminate 8% of cost leaks, even before automation. This is not about heavy governance, just the essentials your team will actually follow. Labels, set a short schema like owner, team, environment, and make it mandatory, not optional. No new resources without these labels are created. In parallel, take the most expensive existing resources and publish a mini label dictionary to avoid variants like ML or machine learning. If you use infrastructure as code approach, bake labels into modules and local sections. If not, add them to code review checklists. The effect is simple: no more often costs report cost reports clearly show who owns each spend. Non-production environments. Turn on and off test environments on demand. For Jupyter instances like Vertex I Workbench, enable auto shutdown. This single rule usually cuts idle cost dramatically within the first week. Compute and Google Kubernetes Engine start new project with smaller machine types, enabling auto-scaling and optimize later based on real workloads. Keep GPU workloads in separate node pools so regular pods don't land there. Create a dashboard showing top underutilized virtual machines, GKE nodes, and Cloud SQL instances. Periodically check for unattached disks or old snapshots. BigQuery, partition large tables, a cluster where it brings benefits, set TTLs for temporary datasets, and add checks on process bytes before running queries to avoid accidental select all queries over terabytes of data. And consider moving from on-demand pricing model where you are charged for BigQuery scanned bytes to capacity pricing model with autoscaler or commitments for predictable and cheaper workloads. Use committed discounts for machine types on Compute Engine, which provide you substantial savings for 1 or 3-year commitment to a minimum amount of resources like vCPU or memory in a specific region. Cloud storage, enable lifecycle policies, move cloud data to nearline, coldline, archive storage classes, configure retention-based deletion, and align regions with compute. Roles and ownership, follow the principle of least privilege. Normal service accounts with editor by default, grant roles for specific tasks, assign an owner for each budget and major projects. The person who either reduces spend, puts resources on a schedule, or consciously accepts the cost for a project. And finally, recommendations on a regular basis. Build a weekly ritual, spend 50 minutes on GCP's built-in recommendations check, pick the top 3 with the biggest impact, like idle right sizing, life cycle, or SQL or compute tips, assign owners and check before and after. Keep a simple count of applied recommendations each month. With these lightweight standards in place, you'll see real impacts on cloud costs even before moving to automation. So once visibility and simple rules are in place, the next step is to remove the dependency on human discipline. The goal is for right behavior to happen by default. With budget and alerts, treat alerts as events that trigger a clear sequence of actions. For example, if a budget alert fires at 80% utilization, the project owner chooses one of a few pre-agreed options, either reduce allocated resources or deliberately increase the budget with a documented reason. The idea is to avoid improvisation and make each response a conscious, well-reasoned decision. Quota and limits put upper bounds where costs can explode, like GPU count per project, high resource machine types, or BigQuery limits. This is not about blocking growth, it's an insurance against accidental escalations. Small teams often underestimate quotas, but they save money when several projects run in parallel. Automatic hygiene, run a lightweight cleanup job daily or weekly to check for unattached disks, forgotten snapshots, or expired buckets with outdated data. This can be a simple script that scans for these patterns and either sends an alert or a ticket. Similarly, Google Cloud Storage Lifecycle rules for achieving or archiving or deleting temporary artifacts should be enforced automatically. And use automated recommendations. For example, you might use Cloud Scheduler to call the recommenders API and send a weekly issue or alerts with the top optimized actions. Scheduler shutdowns. With Cloud Scheduler, you can also automatically shut down virtual machines or GKE deployments, especially in dev or stage environments. Infrastructure as code. If you use Terraform, add policies at the plan stage so resources without required labels cannot be created. This reduces back and forth in reviews. The key is transparency for the whole team. Clear documentation with rules and playbooks showing what triggers an alert, who makes the decision, and what the default action is. In the end, these three steps, visibility standards and lightweight automation, deliver predictable savings without heavy processes. And most importantly for startups, this isn't a quarter-long project. It's a set of practices you can weave into product flow and start seeing impact within just weeks. Let's talk about how to measure results. Our goal is not just to reduce the bill at any cost, but to make it predictable and aligned with business objectives. For that, we will look into two groups of metrics. Final KPIs, these are what business cares about. There should be just few of them, but they must tell the whole story. Like budget predictability. The percentage of months where actual spend stays within 10 or 15% of the budget. Unattributed spend, the share of cost without labels like owners, team, or environment. The target value should be close to zero. These metrics map directly to the free question from the visibility step. What costs the most? Who owns it? And when did growth start? But they translate those answers into the price of outcomes. Leading KPIs. These are what the team can influence every day. They explain why unit costs and predictability are changing. For example, label coverage. All new resources and key existing ones have mandatory labels. BigQuery hygiene, percentage of tables with partitioning, percentage with clustering, where it speeds up our selects. Utilization and right sizing for Google Kubernetes engine and compute. Fewer idle hours, percentage of pods with their requests and limits aligned with GCP recommendations. Google Cloud Storage hygiene, percentage of buckets with lifecycle enabled, share of data in nearline, coldline, and archive states, and trend of temporary buckets. Orphaned resources, trend of unattached disks and old snapshots, and operational process. Average reaction time to budget alerts and number of recommenders applied per week or month. Considering targets for budget predictability, for example, deviation no more than 15% from budget. For leading metrics, we define coverage thresholds. For example, more than 90% of large BigQuery tables must be partitioned. Now let's highlight a few of the most expensive anti-patterns. One-off audits instead of continuous rules. Doing a one-time cleanup of virtual machines or buckets gives you a nice downward curve for a week or two, but and then everything comes up without permanent guardrails like cloud storage lifecycle policies or off-hours schedules or quotas. A config drift is inevitable. The risk is a false sense of control and recurring cost spikes. Yeah. You can see it in the reports. Expenses look like a sawtooth with no stabilization. Bans instead of limits. A policy of you can do anything. For example, banning GPUs or forbidding new nodes slows down product works and creates workarounds. What you actually need upper limits with transparent exceptions, not blanket prohibitions. The risk here is slow releases and the rise of shadow infrastructure. The sign is obvious: more manual approvals and surprise resources without labels or owners. Wrong BigQuery capacity choices. There are two extremes here, and both are dangerous. Staying for too long on-demand billing model when you already have a stable heavy workload, or buying slots and making commitments too early for growth without actual usage. Some case study. One of the examples from my practice of significantly reducing costs was the transition from on-demand pricing model in BigQuery to capacity pricing model. As with many startups, for us it was completely normal to use the on-demand pricing model, but only until BigQuery bills started to grow several times over and it became increasingly difficult to forecast expenses. At that point, we realized we needed to move to capacity pricing with the slot commitments. What we did, we measured the actual demand for slots, identified the stable core workload, and choose capacity pricing with the slot commitments. We distributed reservations across projects and departments. At the same time, we improved schema hygiene, introduced partitioning, clustering, and implemented checks for SQL queries. As a result, this helped save around $100,000 per month and made billing predictable. Of course, this required a certain level of maturity from the analysts and ML engineering teams, as well as developed engineering culture, in order to work within the boundaries of this commitment. But the result justified itself not only in savings but also in manageability. The budgets became predictable. This is the kind of case where the price outcome stops being a random variable and becomes an engineered characteristics of the platform. So let's move to the conclusions. We moved from chaotic spies to a repeatable system, make cost visible, leaks are optimized, and the right behavior is enforced automatically. That's practical FinOps for startups, minimal tools, maximum impact. The key takeaway: don't just ask how much did we spend, ask why cost changed and how predictable the bill has become. Predictability matters as much as the absolute number because it lets founders and tech leads plan confidently and make better product decisions.
Thank you very much. That was really engaging and informative webinar for us. And now we are moving into the Q&A session. If you have any questions, please drop them in the chat box. And there are already a lot of questions, so I think we can start. The first question is, Ivan, how do you introduce cost discipline without slowing down engineers?
Um, Sorry, can you please repeat the question?
Yes, of course. How do you introduce cost discipline without slowing down engineers?
Mhm. This is a good question. I'd say that you need to make the defaults do the right thing and like create templates that include labels and auto scaling, enable auto scaling by default. If you use Vertex AI workbench instances, enable auto shutdown, and of course make weekly based meetups to view the like the situation in your infrastructure.
Thank you. The next question from Dave. What's the best way to get visibility into which projects are driving spend?
Mhm. Um, I think you just you need to use cost breakdown by project or servers and maybe by labels. There you can see what, who, and when uh, the cost was made just on one screen. You can also export this data to BigQuery and create a one-page dashboard in Looker Studio to make it more convenient.
Thank you. The next question from Anne, and about your experience. Was there a project where you wish you had optimized cost earlier?
Yeah, absolutely. Staying on BigQuery on demand for too long. Uh, once we measured steady loads and moved to capacity pricing model uh, with some schema hygiene, costs stabilized and dropped. I do. I would do that assessment earlier next time.
Okay, thank you. And one more question from Anne. How do you balance speed of experimentation with cost hygiene in small teams?
Mm, so I think we should define always on basics like labels and off hours and auto scaling, and let everything else be flexible. So you keep speed, but the guardrails stop the budget from drifting.
Mhm. The next question from Daniel, and he said, like, really useful. Thank you for everyone. Uh, is it okay to ignore some optimization early on and focus on growth?
Yeah, that's totally okay for startups and small teams, but only like for some time or with some optimizations. Because you should set some non-negotiables from day zero, like set labels or budget and alerts and off hours for dev or test environments. Um, Deeper right sizing and commitments can wait for some time, and but those basics are prevent for the worst surprises.
Thank you. Interesting question from Emily. What are the top three metrics you personally track every week?
Yeah, that's a good question. I think the first one could be budget variance versus plan. Second, the share of spend without required labels. We should aim to near zero. And third, BigQuery efficiency. Either it might be scanned bytes if we use on-demand cost model, or slot utilization with the capacity model.
Okay, thank you very much. The next question is from James. He said, thanks, super practical session. Thank you. Is there a way to predict future cloud costs if we grow fast?
Um, yes, I think you need just to start with simple trend from that you might get from billing exports, for example, for last month, 2 or 3 months, then layer it, layer a cost per outcome number, like per active user or per one key events, and project project it with your growth plan.
Okay, thank you. I think it's we have covered everything for now. And thank you to Ivan for leading such an interesting and really engaging webinar. Feel free to connect with Ivan on LinkedIn to keep talking, and subscribe to the Top Voices newsletter and follow us on LinkedIn to stay updated on new events and expert talks. All links can be found in the description below. Thank you once again, Ivan, and thank you for joining us. And we hope to see you at the next session.
Thank
Thank
you.
you very much.